So this is a video that goes through the first few examples in the new packet on solving quadratic equations. So looking at the bottom of the front page where it says Part 1, Example 1. Simplify the square root of negative 100. Right, so as you know from previous units of the year, square roots of negatives are imaginary numbers. Right? And this video is going to show you how to work with those imaginary numbers and how to simplify with those. Right, so what's important to know how to do a problem like this is to keep in mind that by definition, the square root of negative 1 is defined as the imaginary number I. Right, it's written as lowercase, sort of italicized I. Right, so whenever you see an I, what that really is representing is the square root of negative 1. All right? Another thing to keep in mind is that if we square both sides of this, then squaring a square root, they are inverse operations. They undo each other. So I squared is actually a real number, and it's just negative 1. So these are two important kind of definitions to keep in mind throughout this video. So the way we simplify a problem like example 1, square root of negative 100, it's actually very easy. You don't really need to show work when it comes down to it, but I'll show you the first steps if you are showing work. You just take out a square root of negative 1, which as you know is just I. And the other radical, you'll just write square root of 100. All right, so we're just rewriting this square root as the product of two square roots. This one is just I by definition, and this one is just 10, as you guys should know. And I times 10 we just write as 10I. So the answer is 10I. All right? That's all. The next one is the square root of negative 20. Example 2. And this one, same idea. We start by writing the square root of negative 1 times square root of 20. Square root of 20, you should know, that simplifies to 2 root 5, right? Because 20 is 4 times 5. The square root of 20 would be written as 2 root 5. So we have I times 2 root 5. And this is usually written as 2I root 5, or you can write it as 2 root 5, and then outside the square root, write an I. Right? You'll probably see me use this more than this, but this is also a common way to write this simplified answer. All right? And the last one we have is the square root of negative 10. So same kind of idea if you're showing work. This is just I. This can't be simplified. This is just root 10, right? So we have I times root 10, which is written as I root 10, or root 10I. All right? So when it comes down to it, simplifying square roots of negatives, it's really the same as simplifying square roots of positives, of their opposites, just that you got to drop an I in there, right? The square root of 100 is 10. The square root of negative 100 is 10I. The square root of 20 is 2 root 5. The square root of negative 20 is 2 root 5I. The square root of 10 can't be simplified. But the square root of negative 10 then would just be I root 10 or root 10I. All right? So that's the way to handle square roots of negatives. So you would never leave the square root of a negative in the answer. You always just have to simplify it by taking out the I. All right? So those are the first 3 examples. Now let me do the examples on the next page, which are a little more complicated. Well, sort of. So example 4 is just operations with imaginary numbers. So I give you some imaginary expressions, and I ask you to add, subtract, multiply, or divide. All right, so example 4, 2 plus 3i plus 2 minus 3i. So addition and subtraction are easier than multiplication and division with these problems. So all you have to do if there's addition, the parentheses really don't matter. They don't mean anything because there's nothing to distribute. Right? So 2 plus 3i plus 2 minus 3i. Just got to do 2 plus 2, which is 4. And 3i minus 3i, which is 0i. So we have 4 plus 0i. 0i is just like 0. Right? So this is better written just 4. That's all. We're just collecting like terms. Right? So you got to sort of think of I as a variable when you're collecting like terms. 2 plus 2 is 4. 3i, negative 3i make 0i. 0i is just 0. So that would be the answer. All right, example 5. Subtraction problem is really very similar. It's just that there are more mistakes made because you have to first distribute the negative. All right, so with subtraction, it's not as easy as just adding like terms. You first have to subtract this quantity, which means to distribute that negative to both terms. So it's going to become 2 plus 3i minus 2 plus 3i. Minus negative 3i is plus 3i. And now collect like terms. 2 and negative 2 is 0. 3i plus 3i is 6i. So we have like 0 plus 6i, which is better written just 6i. All right? So those are the first two with adding and subtracting. It's just as simple as collecting like terms. Right? Now with multiplying, dividing, it's more work to do. So 6. The multiplication problem first. Multiplying binomials, as always, we just FOIL. Right? So first would be 2 times 2 is 4. 2 times negative 3i, which is negative 6i. 3i times 2 is positive 6i. And then 3i times negative 3i, careful. This is where people make some mistakes. 3 times negative 3 is negative 9. And then I times I is I squared. That's where the I squared comes into play that I mentioned much earlier in the video. So now, okay, we have 4 minus 6i plus 6i is 0i. It goes away. But this, you got to be careful with. Now we now have 4 minus 9 times negative 1, right? I squared, as I said earlier, is negative 1. So we're going to replace, when we see an I squared on our paper, the next step is to replace it with negative 1. So now we have 4 minus 9 times negative 1. So PEMDAS, 9 times negative 1 is negative 9. 4 minus negative 9 is 4 plus 9, which is 13. Final answer to that problem is just 13. It's a real number, right? This is going to happen when you multiply what are called conjugates. Conjugates are the same expressions, binomial expressions with the change in the sign, the symbol. Things will cancel out. Terms will cancel out, and we're going to be left with a real number, right? The last problem is division, which is significantly different, but it also involves some element of conjugates. Right? Now, the way we divide, I is really a square root, right? And we can't leave square roots in the denominator. So the way we handle a problem like this is we multiply the top and bottom of this fraction. We multiply by the conjugate of the bottom. It doesn't matter what's on top. This doesn't matter. Whatever that is not important. We always just look at the denominator, and we multiply top and bottom by the conjugate of that expression. So 2 minus 3i, the conjugate would be 2 plus 3i. Just change the symbol in between or in front of the imaginary term. So 2 plus 3i over 2 plus 3i. The fact that this was a 2 plus 3i doesn't matter. Not to confuse you, we always just use the conjugate of the denominator. All right? And now that we've done this, we have to do a bunch of foiling. So the numerator, 2 plus 3i, 2 plus 3i becomes 4 plus 6i plus 6i, which is plus 12i, plus 9i squared, all over the bottom we did in the previous problem, and we get 13, right? 13 was the answer from the previous problem, so we can kind of save some time with that one. Now just collect some like terms. So 9i squared is really negative 9, right? So we have 4 plus 12i plus this. So 4 minus 9 is negative 5 plus 12i over 13. And the way we're going to write this answer, we're going to split this up as 2 separate fractions. So negative 5 thirteenths, which cannot be simplified, plus 12 thirteenths I. This kind of complex number we'll write in what's called a plus bi form, where a and b are real numbers, so just put the I after that value. All right, so this should probably help you do problems in part 2 and part 1, up to problem 23. All right, have a good day.